Hello everyone, welcome to this channel. In this video, we are going to see the Kubernetes architecture and the various components involved in the Kubernetes architecture. If you are working as a DevOps engineer or planning to work as a DevOps engineer in the future, this video will be very useful for you. Before we proceed, if you are watching this video without subscribing, please subscribe to this channel. I'll post the videos on cloud DevOps tools very frequently. So let's get started with the Kubernetes architecture and make sure you watch this video till the end to understand all the Kubernetes components. So this is the Kubernetes architectural diagram, and you can find this architectural diagram in the Kubernetes official documentation page. I'll provide the link to the documentation in the description of this video so that you can go through the documentation if you need any other details. So generally, a Kubernetes cluster consists of two types of nodes. One is the control plane or the master node, which is in blue dotted lines here. And the other type of node is the worker node. So the three rectangular boxes that you are seeing here, so these are the three worker nodes. So the control plane or the master node is the brain of the Kubernetes cluster. So these control plane components will manage and monitors the state of the Kubernetes cluster. And the worker node components, on the other hand, which provides the services for running the containers and hosts the actual application containers. So you can see all the various components in this architecture like scheduler, etcd, API server, cloud control manager, controller manager, kubelet, kubeproxy, container runtime. So all these components will work together to run your applications in a containers in Kubernetes. So these servers that you are seeing here, so those can be a physical servers or the virtual servers. So let's discuss each of these components in detail and understand the roles and responsibilities of each of these components. So first, let's see about the control plane components. The first one is Kube API server. The second one is etcd. And the third one is Kube Controller Manager, and the fourth one is Kube Scheduler, and the fifth one is Cloud Control Manager. So these five components are considered as control plane components, which resides on the control plane or the master node. So let's understand about the API server first. So this API server is also known as Kube API server. This API server exposes the Kubernetes API. So the clients, developers, or the administrators who wants to connect to the Kubernetes cluster will use this API to connect to this Kubernetes cluster. So when you use this kubectl command, you are actually interacting with this API server. And the API server is also responsible for authentication and authorization, and as well as validating the request. For example, I want to create a pod in Kubernetes. Let's say I want to create a Nginx pod. So for now, you don't need to know about what is Nginx and all, but let's assume I want to create a Nginx pod in Kubernetes. So what I'll be doing, I'll be either running this kubectl run command to create a Nginx pod in dev namespace, or I'll be writing a YAML file for creating a Nginx pod in dev namespace. So once I run this kubectl run command, right? So what it will be happening is first the request will be going to API server, and then the API server will first validate the request, right? What I mean by validate, it will check whether the YAML file will consist of all the required fields or not, and whether the indentation is correct or not, whether the values that I'm specifying is correct or not. So all these validations will be done by API server. And the next thing is authentication and authorization. So let's say the user, for example, in this case, I am running this kubectl run command, whether I am authenticated to this Kubernetes cluster or not, whether I have the required permissions to create the pod in dev namespace or not. So all these verification is done by the API server. And the other thing that API server is responsible for is updating the status in the HCD. So HCD is nothing but a key value pair database. So let's say I want to create a pod in dev namespace. So I'll be running this command. So once the pod is created, this API server will update the status in the HCD saying that this pod is created. And let's assume I want to delete a pod. I'll be running kubectl delete pod. And once the pod is deleted, API server is responsible for updating the status in the HCD, saying that this pod is deleted. Right? So in summary, the API server will expose us an API using which all the developers, administrators, and the clients will connect to the Kubernetes cluster. And this API server is responsible for verifying authentication and authorization as well as validating the requests. And it is also responsible for updating the status in the HCD. The next component that we are going to see in control plane is HCD. So HCD is a key value store. All the information about the Kubernetes cluster is stored in HCD. So all the configurations and the metadata of the Kubernetes objects like pods, deployments, stateful sets, daemon sets, secrets, config maps, etc. So all these configuration and metadata of these Kubernetes objects is stored in HCD. It will also store information about the worker nodes and which pods deployed on which nodes, etc. As we saw earlier, API server is the only component in the Kubernetes cluster that communicates with the HCD. This API server will connect to the HCD and updates the information and retrieves the information from HCD. The next control plane component that we are going to see is controller manager. This controller manager is also called as kube controller manager. In Kubernetes, we have different types of controllers. For example, replication controller, which makes sure that desired number of replicas of a given application is running. And the node controller, which makes sure that desired number of nodes are running. In similar way, we have daemon set controller, cron job controller, etc. And this controller manager will take care of all these controllers. And these controllers will try to keep the Kubernetes cluster in the desired state. Scheduler is the other component in the control plane. This is also called as kube scheduler. The kube scheduler is responsible for scheduling the pods on the worker nodes. For example, let's say I want to create a pod. So while I'm creating a pod, I'll provide some requirements for my applications. For example, I'll specify the CPU, I'll specify the memory, I'll specify the affinity, and I'll also specify the tails and tolerations. So the kube scheduler will take all these requirements into consideration and selects the right worker node for the pods to schedule on. The next component that we are going to see is Cloud Controller Manager. So when you create a Kubernetes cluster in on-prem servers, then you will not have this Cloud Controller Manager. But when you create a Kubernetes cluster in cloud environments like GCP, AWS, and Azure, you will have this Cloud Controller Manager, which acts as a bridge between the Cloud Platform APIs and the Kubernetes cluster. So let me show you this in the architectural diagram. So in the architectural diagram, you can see this is the cloud controller manager. So this cloud controller manager acts as a bridge between the Kubernetes cluster and the cloud provider APIs. This cloud controller manager components helps Kubernetes to provision cloud resources like nodes, load balancer, persistent volumes, etc. And there are mainly three types of controllers that are part of Cloud Controller Manager. Those are node controller, route controller, and service controller. This node controller will help update the node related information by communicating with the cloud provider API. For example, the node's health, node's label, whether the node is available or not. So all these kind of information will be updated by the node controller. And the next one is route controller. This controller is responsible for setting up the network routes in the cloud infrastructure so that the pods which are scheduled in different nodes can communicate with each other. This controller is responsible for creating, updating, and deleting cloud providers, load balancer, persistent volumes, etc. Till now, we have discussed about these five control plane components. So they are Kube API Server, HCD, Kube Controller Manager, Kube Scheduler, and Cloud Control Manager. Next, we are going to see the worker node components. The first one is Kubelet, the second one is Kube Proxy, and the third one is Container Runtime. So let's see each of these components in detail. The first worker node component that we are going to discuss is Kubelet. So this kubelet is an agent running on each of the worker nodes in the cluster. So earlier in the architectural diagram, we have seen we have three worker nodes. That means this kubelet will be running on each of those worker nodes. This kubelet will work with API server and get the pod specifications. And then it will connect with the container runtime to create the containers in the worker nodes. This kubelet is also responsible for creating, modifying, and deleting the pods in the worker node. And this kubelet will also collect the node and the pod status and send those status to the API server. Kubeproxy is the another worker node component. This kubeproxy is a daemon that runs on every worker node as a daemon set. So when you create a service, for example, let's say a cluster IP for some specific backend pods, this kube proxy creates a network rules to send the traffic to the backend pods from the cluster IP service. How this kube proxy is going to do that? This is going to do that using these two modes. So this kube proxy uses these two modes to create and modify the network rules for routing the traffic from the cluster IP service or the service to the backend pods. So there are two types of pods. One is the IP tables and the other one is IPVS. So these IP tables are the default mode, and this is useful when you have less number of services in your Kubernetes cluster. And the other mode is IPVS. This mode is useful when you have more than 1,000 services in your Kubernetes cluster. And this IPVS will help you in optimizing the performance since you have more than 1,000 services in your Kubernetes cluster. So the last worker node component that we are going to see is the container runtime. In Kubernetes, we run our applications as a containers, right? So we need a container runtime to run the containers in Kubernetes cluster. Different container runtimes are Docker, Containerd, CRI-O, etc. These container runtimes are responsible for pulling the images from the container registries and running the containers and deleting the containers in the worker nodes, etc. So let's summarize this video. Kube API server, which is responsible for validating the request coming from the user and also verifies the authentication and authorization of the users. And API server is the only component which communicates with the HCD to fetch the information as well as to update the information in the HCD key value store. And the next component is HCD, which is part of control plane, which has all the configuration and metadata of the Kubernetes objects as well as the Kubernetes cluster. And the next component is scheduler, which will make the decision of in which node the pod has to be scheduled based on the configuration that we provide. And the next component is controller manager, which is responsible for keeping the Kubernetes cluster in a desired state. And the last component is cloud controller manager, which acts as a bridge between the Kubernetes cluster and the cloud provider API, which is responsible for provisioning the cloud resources. And kubelet is a component which is part of worker node, which will get the pod specifications from the API server, and it will communicate with the container runtime to create the containers based on the spec that it will get from the API server. And the next component is kube proxy. This kube proxy is responsible for creating the network rules for routing the traffic between the cluster IP and the backend pods. And the last worker node component is the container runtime. Since we are running our applications in Kubernetes as a containers, we need a container runtime. So the major container runtimes are Docker, Containerd, and CRI-O. So please like this video and subscribe to this channel so that you won't miss out on my next videos. Thank you.